don't have any sound. Hopefully this is working. We'll find out. Here we go. Hey, we're live, 7th hour. Is this 7th hour? Okay. This goes nowhere. This goes into my Google Drive. It's like not even I hate it. This new little video software. Can't even put it into YouTube unless I do a download and then redo it. It's blah, blah, blah. Remember what I said about conic sections? They're sections of what? Cones, not conics. Okay. Cones. Remember the cup I was trying to get you to imagine? There's a circle. We already did that cross section. What I like about this too, let me get my fat face up here. All right. Is they show the cross sections over here, and you don't see them in color, so it may not be so obvious in that little half sheet there. But then I talked about coming through at an angle. That'll be an ellipse. That'll be next after parabolas. Cutting through parabolas, and then this thing that I said you have to put two cones together and cut through once like this. You get these two looking parabolas, but they're actually called hyperbolas with a little bit different features. So, that's what's going on there. And let me see. Oh, I hope you know what? I'm going to cheat. Don't look. Okay. A lot of math here today. All right. But I want to show you this. Here's why we have to know what we have to know. And you're going to have to draw this over to the side here. So I put a little coordinate plane here. I just didn't feel like drawing this again. This is why we're doing parabolas again. We already did parabolas when we had these two in front of me here can pay attention. We already had parabolas in this form. I feel like as the day goes by, my voice gets worse. Okay. Oh boy, we got our hand up already. Yes, you can have water. Yes, you can. Oh wait, what? How would we move you up here? But let's switch. Let's pause the video for a minute. Hold on. We're gonna switch you guys. Okay, wait, hold on. How do I get this paused? All right. Anyone else want to move? All right, too late. So I'm gonna sit in this one desk all by themselves. Okay. So we did do y equals ax squared plus bx plus c. Don't even write that down, no. Which way did these parabolas go, though? Which direction? Only what? Up and what? Down. Just remember that. But now we're going to change it. But we're changing what we're looking at in a parabola, some key characteristics. So that's why we're changing the format. That's why we're doing them again. In another way, we're also going to have them go right and left. So that's another big change. Okay, but and you should have read this off to the side. You have this notes set in front of you. You can read them. What I want to do is zoom in on this. So it says over there now, we have to concern ourselves with two things, a focus and a directrix. Okay, because these two things, like this happens in sort of, with imaginary stuff out in space, but things have parabolic motion in space. And there are these imaginary things that do dictate their movements. It's all through gravity. All right. So anyway, don't get too deep into that. One of my links that I'll share with you later as we get into conic sections more is spatial movement and how is it elliptical, how is it hyperbolic, how could it be parabolic. It all depends on certain attributes. We won't get into too far. You won't have to do that on a test. It's just interesting. But it also dictates why we have to find these things in our little Mickey Mouse class in case you move on and do things that deal with that. So here's the focus. Notice I put little P's there. I would put those in there. P is going to be the key today. P is the key. Right. That's something that my junior year math teacher, all the way back in the 1980s, Mr. High was his name. Give him credit. I remember him to this day saying that in class when we were doing parabolas. Isn't that wild? But here's how it makes this graph. It says so over here. The graph, any point on this graph, stop. This point right here. The distance to this focus will be equal to the distance to the directrix. Now, how do you get to align the distance to it? You draw a perpendicular to it. That's the shortest distance. If I went slanted here, that'd be longer. That's because that's not a perpendicular. So how do you get to a line, a distance to a line, a perpendicular to it? These two distances, D1 and D2, are equal. Okay. So what have we established? That there's these new things. Well, guess what? We're going to have to find them now. All right. Mathematically on our piece of paper. So that's what we've dictated here. Fifth hour, I had them read this. You guys all want to read this sentence now? Ready, set, go. Since, keep going. Parabula. All right, go ahead. Dracula. Nice. This is getting kind of creepy. Right. That was 20 times better than fifth hour. You're gone, fifth hour. All right. So I'll get back to that in a moment. That was excellent. I hope it you can hear it. This microphone's very specific, but I also did this. I made these notes. I wanted to show you where parabolas are in nature. Huge in architecture. Actually, in architecture, the parabolic arch is very strong structurally. I can't believe I didn't take pictures of the aqueducts in Rome, which are like thousands of years, maybe like 2,000 years old. And that's why Rome was such a strong country. It was their infrastructure in roads, aqueducts. They just had stuff that made their people healthier and stronger as well. Very smart. This is really big. I'm going to show you a video tomorrow because we do have time for it, I hope, about the Hubble telescope. Raise your hand if you know about the Hubble telescope. Okay, you're going to know more about it tomorrow. But this is what a telescope does, or just a Dish Network. It's so funny. Dish is kind of going out because it's all streaming now. But you know what a dish does? Sure, signal comes in and hits right at that receptor. Do you know where that receptor is located at, by the way? It's located at starts with an F, and you just learned the word today, focus. This is why we're covering this stuff. This is why we're talking about this. I guess in the video you can kind of see this. So what happens? Some of the signal hits right on that focus. Any of the signal that doesn't bounces off the dish. There they are. I can see them. As soon as you two need to be separated or something. This is not grade school. All right. Anyway, the signal hits this dish and then goes to the focus. So this parabola, parabolic, it's actually called a paraboloid, a three-dimensional parabola. Um, focuses the signal to the focus so you get a clear picture. That's why we're going to watch that Hubble telescope video. That's just water, but bananas. I don't know. I just was getting crazy with pictures that look like parabolas. Anyone ever see a flashlight? I used to. Did I have Is McDonald's in there? Are the golden arches on there? Oh no! I should have put that in there. Those are two parabolas. But here's what a flashlight has. A flashlight has a light filament, and then some of the light goes straight out. That's probably that real that you never see an old flashlight. There's a real lit up spot, and then everything around it. And then the light bounces off a mirror and then directs it forward because that mirror is parabolic, but the light filament being at the focus. And that's why the light gets directed forward the way it does. Right. So that's why the light filament has to be at the focus as well. Bananas. All right. Same thing with the dish. A better picture of that dish. I am so surprised I don't have the golden arches there. All right. And then roller coasters have a lot of parabolic, a lot of different shapes in a roller coaster. So Fatermac, Mr. Stronowski's son, is at Iowa right now in his second year. I'm not sure if he's going to follow through on this. His dream, though, is to be a roller coaster engineer because he's obsessed with roller coasters. We've been on many vacations with them. Pretty awesome. He really into that stuff. Okay, now I got some old notes here. Now this is where you probably want to grab a highlighter and have some stuff stick out here. Got a lot of terms in here. It's fine. I'm going to focus on standard form. First one I'm going to do is didn't I just tell you? Didn't we already deal with x squareds, right? Didn't we already deal with x squareds? Which way did they only go? Up or down? But we're not dealing with that form, but I just want you to remember, you graphed these already up and down. So x squared is still up and down, but now it's a different format. Who is the key? P is the key. Okay, so now we're going to rewrite this equation in a different format. X squared equals 4py. And what is p? I'll tell you in a minute. First of all, which is a positive direction, up or down? Up. So this is all that this says. You're going up when it's an x squared, and p is positive, or you just have all positive numbers. That's all that this says over here. And if p is negative, that means negative. I probably should have just posit is not the shorthand of positive. So it just means p is positive. Yes? Then it would not be anything. You would just have x squared equals 0, right? Because it would crash everything on that side of the equation. Man, I don't know why my voice sitting here all last period grading. I feel like it's worse than fifth period. Weird. All right, now let's go over here. For the first time in forever, you now have a y squared equals a 4px. What I used to tell, I didn't say this in the other hour. That means for every x, there's two y's. That's what that means. So that means when I go to a coordinate plane, when I have an x, there's two y's. The only way that could happen is if you were going right or left. You know, and then the same thing over here. For every y, there's two x's was another way of knowing that for every y, there's two x's. The only way that could happen is if you're going up or down. I'm not drawing a down one. All right. So other ways you can think about x squared is up, down, y squared is right, left. By the way, what's a positive direction on the x-axis, going right or going left? So this is positive. Guess what? You're going right. This is negative. Guess what? You're going which way? Say it. Okay, then when you say it, you just increased a little wrinkle in your brain. Everyone okay so far? Who's the key? P. Now, guess what's going to take care of all this? You guys read like drones. Did you read or did you really read? What's the parabola? This is what you do in the morning when you get up. You go to the fridge. The parabola is the bowl. What's the focus? And then what's the directrix? So I actually do this. Serial bowl table will take care of all of this. Because you know what this is? This looks like something I have to memorize. This looks like something like, oh gosh. It's either y equals or x equals. It's either 0 comma p or p comma 0. Oh, there's too many things. Wait till you get to ellipses. There's bigger rules. Wait till you get to hyperbolas. There's even more rules. And what I'm going to approach it's not serial bowl table for them, but your file in your brain is file it away. Parabola is a serial bowl table. It will take care of everything you need as far as locating stuff. One more thing. It sounds like a naughty word. I don't understand why this is called this, but the focal width is called the latus rectum. Did everyone say latus rectum? All right. So this is I'll show you this later. This is called the focal width. And then I'm going to show you how it works in the graph. All right. But it is equal to that 4p. Wait, there's 4p in the equation, and this says 4p. By the way, what do those two straight lines mean? Absolute value. So that means when we say what is the focal width, we're going to say a positive no matter what. Okay. And that's all we have to say. And then I don't know. This just tells you the format we're going to do. I'm just rolling into it, man. This is for someone who might read the notes, fumble, and try to read them on their own for pattern. This first one's not the best though, but it's our little parent function is what we used to call this. And actually, it's written in the wrong way now. We write it squared equals non-squared. That's the way we want to watch this. By the way, what number's in front of y? 1. And I'm going to compare this to the equation that I gave you for up-downers. It's supposed to be in the format x squared equals 4py. I bet you someone will be able to do this. What is p? Don't say it yet. What is p then? Now all you have to do is compare this and compare this and then see what P is in your head there. 3, 2, 1, go. Oh, nobody got it. No, it's a fraction 1/4. P is 1/4. How do you do this? Here's the equation. Here's what it's supposed to look like. 1 is in the 4P position. What is P? Set those two positions equal to each other and solve. This is why this one isn't the greatest. We're going to have a lot of fractions here going on. So P equals 1/4. Now I will tell you this, and I'll probably tell you this at the end. How does this non-very descriptive homework work? This first one, I just give you an equation. So what do you have to find? You have to find then the focus, the directrix. This is the last time I'm writing these out, by the way. And let's call it the focal width, not the latus rectum. Go for it. Okay, but before you do that, cereal, say it. Bowl, say it. Table. Now, I didn't give you this here. Let's find it up at the top here. Here we go. Someone fifth hour. Dang it. Calls it parabola, and you just got me to say it. The vertex for all of these will be 0, 0 today. Then tomorrow, we'll watch the Hubble telescope video and then also change that. Guess what letters they use for new vertex values? Anyone? Anyone? H, N, K. Common thread throughout the whole thing. So you also have to graph. So they give you an equation. You have to find all these and graph. But actually go to the graph first. Serial, say it again. Full table. This one's annoying. So we're going to go like this. This is 1. This is -1. This is 1. And this is -1. Just do it. Believe me. Because this is a very small p-value. So P is the key. I haven't told you this yet, but I actually did. Let me look at the original drawing that I have up here. Oh, shoot. I have to go to my other set of notes. The original drawing that I have up here. Oh, shoot. It's not that one. The original. There we go. Look at what I put there. What are these two letters right there? What are those two letters? P. This is why P is the key. What were we on the second one here? Yeah. P is the key because it is the distance that I move from the vertex. Now, where does the focus belong if this is going up? Where does the focus belong? Does it go up, down, right, or left? Now it's serial bowl table. Up. Why? Because the focus is the serial and it belongs in the bowl. Don't draw that yet. So the cereal belongs in the bowl, no matter which way the bowl's going. The bowl's going to be weird. It's going to go sideways. It's going to go upside down. If you do that tomorrow, you're going to get grounded because your cereal is going to go all over. But we're going to pretend there's no gravity and I do this. Well, then I could just float the cereal here and then the direct. By the way, what if the bowl was going this direction, which is right? Where should the cereal be? Which direction? Right. And then which direction should the directrix be? Where should the table be to put the bowl on it? To the left, and then what kind of line? Straight? No, what kind of line is this? Vertical. All right, so that's why cereal bowl table is going to work. So the focus belongs here. How far did you go up? How far did you go up? How far did you go up? 1/4. So what's the focus? 0, 1/4. This is why I love doing conic sections as well. You get a lot of coordinate plane work. Goofballs that put 1/4, 0, you've not been in a coordinate plane long enough. You make silly mistakes. And then for the directrix, I got to go down and draw this dotted line. How far did I go down again? 1/4. What is the equation of that line? Is it x equals or y equals? Now, did you hear that pause? Everyone's like a little scared. Okay, and this is another reason why I like this. It's y equals. That's the equation of a horizontal line. If you put x equals, you're completely and totally what? And you're definitely what? Gone. Okay, so it's y equals, I went down a fourth. And then what's the focal width? The focal width is just this number. So the focal width is 1, the number that's in front. But how do I incorporate that into this graph? It does say so up there what the focal width is. I'll paraphrase. The focal width is how wide the graph is, or connecting the two endpoints going through the focus. So the endpoints right here that give me shape will be one away from each other. That means how far do I have to go that way and how far do I have to go that way? It's a fraction. No, because 1 plus 1 is 2. Half. Okay? So I have to go half this way to graph this point. So that is at a half. And then negative half that way here. And then I could get those points and tell you what those are. All right. And then that's all you're responsible for graphing, using the focal width to get 2 more points. Okay, let's move on. Let's actually do another one. Wait a minute. There's no equation on this one. So guess what you have to find? You find the equation, any missing material, and then also graph it. Okay, so the vertex. Well, of course, you know what? In another question, they don't tell you what the vertex is. Why? What is every vertex today? 0, 0. So that happens later, but it should be told. Tomorrow that ends. Tomorrow you'll be given all the information when it changes and all this other stuff. And then the focus, which way is that? 0, -4, up, down, right, left. 1, 2, 3, 4. Okay, everybody, because of serial bowl table technology, which way is this going? Up, down, right, or left? 3, 2, 1, go. Down. The table must cover the cereal. The cereal must be in the bowl. This is why cereal bowl table is the best technology ever to do these. But don't graph it yet. You have to do the focal width for the graph at the end. So what's an up downer? Is it x squared or y squared? Which one's squared? Which one's squared? X. And now you write your little, this is not the equation, but it will be real quick. P is the key. What is P, everyone? It's right in front of you. What number is P? What kind of 4 though? Because it's going down. So you don't really have to say what P is. If you said P was 4, I wouldn't mark you wrong. It's all about putting everything right as far as where everything's located and what the equation is. So then what's 4 times -4? This is actually the equation, which is what it was missing. So now I have to find it. But now I have to finish the graph and then actually also find the directrix, which is missing. Okay, D is directrix. I'm not writing the word anymore. You're in honors. You should be able to. I can't write a T right now. Yeesh. Okay, so D, what's the directrix? Well, which way do I have to go for the directrix if the bowl's like this? Which way? Up. Up how far? 4. P is the key. So I P up. What? And then what kind of line is this? What kind of line is this? A dotted line, a straight line, a red line. Let's get all that out of our system and then tell me what it is. These kids. Okay, so what's the equation of this? X or Y, for the love of dog. We just had one previous to this. Is it X or Y? Y, and it's Y equals 4. Last but not least, the focal width. We're just saying FW or LR if you want. Hey, the focal width is 16. So these are 16 away. So how far do I have to move this way and how far do I have to move that way? 8. Let's just do this. Every graph is going to look the same today. Just put 8 here and put -8 here. Just because. But guess what? Guess what I'm going to do now? What's my number one? What's the thing I say the most in this class? You're gone. Yeah, well, that's because of students. That's your fault. What else? For those that don't answer questions and sit there like lumps. But no, someone just said it. Input, output. Guess what this coordinate is right here? Don't guess, it is 8, -4. I throw this in this equation, watch what happens. 8 squared equals negative 16 times negative 4. True or false? True. That's why, remember yesterday when we did that tangent line thing and it was x squared plus y squared equals 37 and 6 comma 1 was a coordinate on the circle? Why? What's 6 squared? What's 6 squared? What's 1 squared? What's 36 plus 1? That's why x squared plus y squared equals 37 has that coordinate. You're crinkling your eyes. Are you okay? All right. So this is true. And then guess what? This coordinate, we're not going to bore you with this. What's a negative 8 squared? What's a negative 8 squared? What's a negative 8 squared? Still 64. So if I plugged in negative 8 in that spot, I get another true statement. Input, say it. Oh boy. Okay. You're lucky you get the vertex here. Now, what's the matter? What's all the hubble out there? What's the scuttlebutt? What's going on? Huh? What did I do wrong? What did I do? Oh, I didn't write focal. What is the focal width, everyone? I mean, yeah, I didn't write it, but we talked about it. You're right. Sorry. Yeah, that's what everyone does. Like a murmur out in the crowd. Okay. It's another big word for Mr. Samuels. Murmur. All right. So it opens left. Is this? It says so. So is it x squared or y squared? Y squared. Guess what we're gonna do at the end? Input. Say it. We're gonna prove that it's a y squared after we do our stuff. As far as the information I'm giving you, which comes out of left field, the idea of a focus existing and all this other stuff. Okay, so I'm at 0, 0. They're going to stop telling you this. It's just the whole day today. Then after today, we'll tell you what the vertex is. We're changing that tomorrow. And then, okay, fine. I'll do the tick marks. 2, 3, 4, 5, 6, 7. Which way specifically does this parabola go? Right or left? 3, 2, 1, go. Oh man, you guys don't know where to put your cereal. I'd like to see you guys in the morning. You put your bowl sideways, then you pour your cereal like this, and then it's hitting off the side. Guys, you put the cereal in the dang bowl. The bowl has to be going left. Let's get the cereal bowl table technology figured out. All right. I wish I had a bowl in like this. Here's how I pour my cereal. Ding 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 ding. Anyway, it's going left. So what does that mean? P is positive or negative? What does that mean? P is positive or negative? Negative. So what is P? What is P? It's staring you in the face. The number's already been given. What is it? It's what kind of 7? Technically negative 7. If you said 7, fine. But you better, what's 4 times 7? You better have negative 28 or else this is wrong. Can't be positive 28 and negative 28 means. You just need to know 7 is your movement. So what do I do for the directrix? I what? P right, 4, 5, 6. Wait, 1, 2, 3, 4, 5, 6, 7. Then what kind of line is it? Straight, red, dotted, vertical. Someone said horizontal. What's the equation of a vertical line? So I have, actually, I guess I have to find the focus because it just told me that information. So this is negative 7, 0. And you will write coordinates because I will get goofballs that say x equals negative 7 for the focus. You're what? Gone. Come on. And then the directrix is y equals or a coordinates, all these goofy things. You must have math syntax. So it's a real training on math syntax. That's why I love this chapter. CAT students don't get it. I'm very the CAT's really made me sad what AP did to it. Because we don't even get to do conic sections now. What is the focal width? This is going to be weird. What is the focal width? Nope. It's still 28. I heard someone say 14, though. Ready for this answer. How far do I have to move up and down to get these other two coordinates? Say that number again. 14. Because this is not really, and I don't want to do tick marks. I really don't. But what I am going to do is input, say it. I am going to prove that these are two coordinates that work, and hence this has to be going left. This matches the data. I have a focus that's 0, 0. By the way, input, output. You throw in 0 into this, 0 squared equals negative 28 times 0 is true. So this is true, input, output. Let's check one of these. Careful, this is left 7 and then up 14. So that's what that coordinate is. You always like showing us this is not mandatory. You don't have to do this, but I'm proving something to you. I'm proving that, sorry, I had to catch myself. It's y squared, 14 squared equals, you can type this on your calculator, negative 28 times x, which is negative 7. And I know 28's 2 times 14. I move the 2 over to that negative 7. I have negative 14 times negative 14. I know these are equal. This is a check. This is proof that this is a solution, which is on the equation. And then this is negative 7, negative 14. What's negative 14 squared, though, everybody? What's negative 14 squared? Still a positive. So it would still equal that input of negative 7 on the x. So again, this is what it means to be a coordinate. It solves the equation. All these things I think students really do not know. Oh, the input outputting in my CAT class, it's just mind numbing. All right, so what do I do to both sides? Because this is not in the right format. This is supposed to say y squared equals. What do I have to do to both sides? Times both sides by what? 36. I shouldn't have to write that on both sides. All right. And then which way does this go? Right, left, up, or down? 3, 2, 1, go. Right. It's only right or left. So you have to have two things here. I know it's new. I know you walked in, you've never seen this before. But this is the one thing you got to figure out. X squareds are up or down. Y squareds are right or left. Positive is a right movement on the x-axis. All right. So what is P? Bet you people can get this fast now. What's P? 3, 2, 1, go. Oh no. 9. So this is supposed to be equated to y squared equals 4px. Where'd the 4 come from? Formula. It's a formula. Just like where did the opposite of b plus or minus square? Okay, we're good. That's a formula for solving quadratics. That actually does come from something. This does come from engineers figuring out that this is the relationship. I don't know. Right. So I guess some people might be thinking, where did you pull this out of? All right. It's just a thing that's accepted that happens with motion out in space and architecture and blah, blah, blah. Okay. So here's the, see? Actually, we'll tell you why you should know the vertex is at 0, 0 tomorrow. It's pretty simple. It's very similar to the circles. All right. But which way do I have to go for the focus then? Right, left, up, or down? For the focus? Right. I'll do the tick marks. 3, 4, 5, 6, 7, 8, 9. Why? The bowl is going right. The cereal. Don't draw it. Don't draw it. The bowl is going right. So the cereal belongs inside the bowl, sitting there waiting for the milk, even though this is a sideways bowl. And then which way should I go for the directrix? 1, 2, 3, 4, 5, 6, 7. And then draw a dotted line. What kind of line is that? Red, straight, dotted, vertical. Okay, so now I have to do my stuff. Here's the focus. The focus went right 9. Did I go 7? 4, 5, 6. No, I didn't. 8, 9. Did you see that? I added 2 more tick marks in the middle. All right, 9 comma 0. And then what's the directrix? X equals what? Negative 9. If you don't have the x equals, what's going to happen to you? You're gone. FW, what is the focal width? 36. What does that mean? I have to go up and down. 18. This is for input, say it. But it's really not that. You're not going to input output. You better darn well mark these points, though. You better mark these points. And because I have just a not general coordinate plane, like no marks on it, and I don't want to do 18 marks, I'm just going to go right to 18 on both of them. And then you could play yourself if you wanted on the input output 9. Sorry, that looks like a G. 9 comma 18 would work when I plug it in my equation that I have. All right. And so would negative or 9 comma negative 18. So 18 squared, big number, 9 times 36. Hey, take a 2 away from 36, that's 18. 18 and 18. So this would make the equation true. Both of these would. Negative 18 squared is also that big number. I don't know 18 squared. 8 times 8 is 64. 20 squared is 400. 8 times 8 is 64. It ends in a 4. 324. Can anyone check what 18 squared is? Am I right? Boom, shakalaka. All right. It did come, I did figure it out. Okay, 2 more. What? Oh, I don't want to learn. Is that really it? What? What is going on? What's this? Okay, what kind of line is this? Straight, red, dotted, and also which way is this going? Which way is this going? Up. It's x squared equals 4py. Why? Table. This has got to sit on the table when but it doesn't sit on the table, but it's got to be appearing like it's going to sit on the table. What's p? We already got it. What's p? 5, but it's actually positive. Why? Which direction is this going? Up. So p is technically 5. That means you go up 5 for the focus. That's at 0, 5. So I will speed this up. The directrix is already drawn. That's already given. What am I doing? Then the focal width, because I know p is 5, 4 times 5 is 20. And then I can go to, I can. There we go. We got our I can statement. Thank goodness. Oh, I'll be fired as a teacher. You didn't say I can statements today. This whole lesson is invalid. All right. See how fast we did that? And then as you're packing up, I'll do the last one just for the video. Is this in proper format? No, Mr. Samulus. What I would have to do is subtract 24 from both sides. So this would be negative. Well, who's coming up here? Oh, okay. I'm getting attacked, I think. All right. And then which way is this going? Up, down, right, or left? The answer is down. What's P? P is the key. Well, no, but what is it specifically? -6, because 4 times -6 is -24. So that means since this is going down, you go down 6 for the focus. So there's the focus. 0, -6. And then the directrix, you go up 1, 2, 3, 4, 5, 6. And it's a horizontal line at y equals 6. And then the focal width, of course, is 24. So that means you simply go 12 and 12 on both sides, negative, for these 2 points here to draw a graph. Input, say it. Output, someone did say it. If I found these coordinates, they would make the equation true. 12, -6. Nope, you're all packed up. You can go. I just wanted to finish the video.